This time it will be a more in-depth tutorial. We will be creating a scene with Effex 2.0 of an open water scenario at a coastline, and I have prepared a simple scene here. We have a landscape. I used actually a Sim4D landscape object to just model this quickly, so we have something here. I also created a volume for it. When I use the angle limit, you can see what I have done. I just simply thickened this whole thing. You could also use a clothed NURBS, for example, with a thickness value, but I did this by hand by selecting all the polygons of the original landscape object, and that we can see here, and then simply making an extrude command and pulling all this downward. So the landscape actually has a volume, an inside, if you want to see it like that. Alright, so that's all I need, because I want to use this as an obstacle in my simulation. So it has to be a volume. We can't simply use the landscape object, which is in the end just a surface. Well, create first of all the water that I would like to be in here in this area, and then I want the waves to come splashing over these rocks here. Alright, so I always start with a preset. In this case, the open water wake preset is perfectly for this task. I also made the scene so it fits directly in here without doing much. But let's just take a look again at that preset. We have a volume with a cube, and that's where the particles are actually being emitted. You can see it now here if I go frame 0, and we have an obstacle, this one here, which we don't need actually anymore. Instead, what we can directly change is our landscape that we want as an obstacle, of course. So I can simply replace it like this and drop here in the mesh object of the original obstacle volume. And we can see that this is an obstacle because we have that obstacle tag here. So we could make any volume an obstacle by right-clicking, going into the Effects tags, and choosing this obstacle tag here. And as soon as this happens, the whole system registers this volume as an obstacle volume. Alright, so that's all we need to do. Our landscape, as we can see, if I turn this off, the visibility has been registered correctly. I can see the inside of my landscape being displayed as red, which is correct. This is the inside of our volume, just as we can see here with the volume of the cube. Here we can see it simply shows the inside of the cube in a reddish color. Alright, another problem by now. First of all, let's go on the top view, activate this volume again, and make our landscape visible. And we can see now that we don't have any water in here, in this area. So what we need to do is we increase the size of the cube. Just make this 800, and nothing happens. What's the reason for that? Well, although the cube is now the 800 wide, it doesn't emit into this area because our liquid solver, this one, which takes care of all the dynamics and obstacle handling with the liquid particles, etc. We can see its bounding box here shown in dark gray. That's the domain where all the dynamics are happening. Everything outside is not considered for the simulation. So we need to increase the liquid domain first of all. 800, and we can see that instantly the space where the cube, our emission cube here, and I just renamed this for better reading. directly emits into this space. But we have another problem now. Back here in this area and also this little space, I don't want water to be there. I mean, there's no reason. We will be coming with our camera from this side. I don't know, maybe standing still or having, you know, just some movement or some zooming, etc. And that water down there isn't visible and it has no use to us. So we got to get rid of it. And what I can do for this is, of course, I changed the emission cube polygon object. I converted it now to a real polygon object. Before it was a primitive. Go into polygon mode, activate it, and now I select this polygon here on the side, go into the top view and just make it smaller like that. I could also increase the cube size a little. Now that we have this, and we can see there is no water generated here and also here, not anymore. So this is looking great, just as I want it, but we still have a problem. If I turn off, well, let me just make this one invisible again. And if I make the landscape invisible, we can see that particles inside of the landscape are still emitted. You know, and of course we don't want that. We only want particles outside of the obstacles. What we need to tell the grid emitter, the particle grid emitter, which is taking care of the emission, we need to tell it, okay, please do not emit particles inside of the obstacle there, that volume, that landscape volume, that coast obstacle. And we can use constraints for this. So let's create a constraint, and in this case a volume constraint, and put it down here. Whoopa. Alright, and this constraint now of course needs the volume linked, and we can use the canon button here. We have our coast obstacle that we will definitely use. Alright, so if I now turn off the landscape, make this update, nothing happens because we still need to assign it here in the list of constraints of the emitter. Oh. Alright, so now we can see something happen, but it's actually the opposite of what we wanted. It's now emitting only inside of the landscape. So in order to change this, we simply use the invert option in the constraint, and now it's only generating particles outside the obstacle as it is defined. Swoop. Yeah, that fits perfectly now. That's much better. So I do this because, first of all, we have less particles, and this all results in faster simulation. Less particles means less calculation times, and also the size of the underlying three-dimensional grid that is generated. We can see it here. Now that I've gone to frame 1, we can see now the voxels, or the voxel size of this adaptive grid, which is shown in white. And if I go to the top view, you can see it only reaches until here. And this area that would have been otherwise been calculated and would have stolen us valuable simulation time is now not taken into account anymore. So we've done everything right. We know this is an open water scene, and we would like to have some waves, of course. So what we need are some forces acting on this. And we have a particle force acceleration, which is taking care of the gravity in this case. As I know that I would like to have Effex particles being generated as foam and spray, I rather turn this off now and go into the Effex scene and use the global gravity value here, because this will also affect my spray particles later. And this is just more convenient. Alright, but I can use this force now for my own purposes. You know, I want to perturb the surface area of this water so I can actually directly affect the particles and use this particle force. And if I now change, for example, the acceleration direction here to along the x-axis instead of the y-axis that we had before, we will see, and just show you this effect now. You know that we have a lot of motion here going on into the negative x position. Swoop, and why not turn it off, or let's just play this game and just push it back into the other direction a little bit so it doesn't go over the coastline, like this, like this, like this, like this. Come on, come on. Now they're kind of stopping and they're now pushed back into the opposite direction. I could not turn it off. I could also key this, by the way, and well, that would actually be a great ground truth for our for getting some larger scale motion into our simulation, because it will hit that boundary now here, and you can see it will be swapping back with some waves actually being generated here now. We can also see that this is all into one direction, and I could simply alter this, for example, to get waves more diagonally from this side or from this side, and just put 0.5 here for the direction. Turn it on again. And now we could go on like this all the time. I had two forces actually now. The first one was actually only to the x, along the x-axis, and the other one was a little more diagonally with along the z-axis additionally. And I can simply, either I key this or I simply create several acceleration forces now, and I set this one to a minus. We had 10 here, we had 0. I keep this maybe with a 8, and maybe I create a third one like this, and this time I would like it to be more random, and for this I can create now an alignment object here, because we, in our normal force default settings, we cannot set any random settings. We need something that gives us this random directions. And inside of the alignment object, I use this little arrow here of Cinema 4D, very handy. You don't have to change into the actual object here. And here inside of the alignment object, and I do this just more clear for you, we have the direction mode, and I choose the random here. So it will now, whenever the acceleration force asks to emit a force and the direction that it should emit into, it asks the alignment object, and the alignment object will return a random direction to our acceleration force that uses it. Alright, so this is pretty handy, and actually that's all we needed to do. But what I would like to do now, of course, because if I turn these on and I still have to do something, I need to drag the other two acceleration forces here into the particle group for the liquids, so they are all registered as acting particle forces. If I play this, it will all happen, of course. And we can also see how the random acceleration is hitting this. it works, but it doesn't stop. So we need to temporally constrain this. And we can do this by using a duration object. Here we have a slot in the force, and we already have a duration here in the scene, which is for the from the particle grid emitter for emission of the open water body liquid particles, which are only created at the first frame. So if I use that duration, I know that these forces of the acceleration object will only be applied in the first frame. Well, I'm not sure if that's what I want, so I create another duration object like this, which is put down here, and I put it here because it should be working for all three of these, and it's just a better overview for myself. And boop, I drop it here with a multi-selection of all the forces. Now it's in there. Okay, so let's just go into the duration object here. Now I love to set things in frames. I don't know why. Sometimes it's better in seconds, but this time I use frames. And I set, I don't know, maybe 4 frames, the emission of the forces that we now defined. And go back into the random one. I'm not sure if that's, I'll set it like this. And maybe I also, well, let's just take a look how this looks like with 4 duration frames. Well, not much happening actually. Pretty boring. Maybe I want this acceleration. I call it X because it's along the x-axis. I put a little more effort in here. Like, I don't know, 36. Here I put 16, and the random one will again be 40, 14 maybe, yeah, 14. Yeah, it's alright.